Looks like it's time to check the old mailbag. Let's take a look. This letter is from Laurel, and she writes, "Thanks so much, Andrew, for all your amazing videos." You're very welcome. I've been using MarsBar to write my clusters for viewing on MRIcron. However, these images are binary. I know you're not very smart, so let me explain what binary means. It means that the map is only ones and zeros. Ones where the cluster is and zeros everywhere else. I wonder if there's a way of saving a cluster as a heat map so that you can see the cluster peak. I use SPM mostly and some FSL. Thanks. P.S. You move your hands a lot. Charming. Well, Laurel, yes, there is a very simple way to do this in SPM and virtually every other software package that has some sort of calculator tool, something you can use to multiply any two images together. Now, I'm assuming that you're talking about a contrast that you're using as a mask because a contrast in its normal state has an activation profile which you can use as a heat map. However, with MarsBar, you end up generating a mask which is only ones inside that mask and zeros everywhere else. So the trick is to just multiply that binary mask by the activation map. So now we're going to have the activation information just for that cluster, but exclude everything else. Let me show you how to do this in SPM. So assuming that you've already run MarsBar and you have your binary mask, all we need to do is use IMCalc. First of all, let me show you the binary mask that I have. Let's say that this is some contrast, let's say errors minus correct, that elicited activation in the anterior cingulate cortex. Now when I took that, let's say cluster corrected contrast, this is what it looks like when it comes out of MarsBar. It's just binary, and it's only ones where the activation was and zeros everywhere else. If I overlay this on top of a brain, this would mostly be within the anterior cingulate cortex. When I'm using IMCalc, all I need to select is that image that I output from MarsBar and also the resulting SPMT image that I got from, let's say, an individual level or a group level, whatever I'm interested in right now. This is an SPMT contrast map that was generated from this same second level analysis that I extracted my contrast from. So in other words, the SPMT map is going to have the activation information, it's going to have intensity, and the binary is the mask that was generated by MarsBar. So click Done. Let's call this output file name ACC heatmap. Output directory is fine, and the expression is going to be I1 dot times I2. Remember, dot times is just MATLAB notation for multiplying two matrices together, because in this case we are multiplying two three-dimensional matrices together. I1 and I2 are just placeholders for both of those images that we input. And then hit run. So now what we should have, if we boot up MRIcron, is a heat map. So first let me just show you the binary map, what that looks like. So if we threshold that normally, it just looks red, or we could put this in blue or whatever other color scale, but there's no differentiation. It's not a heat map because the intensity is uniform everywhere. But if I close those overlays and I add the ACC heat map, the result of multiplying, now we have some intensity information. And this becomes more pronounced if I use something extremely sexy like the hot iron color scheme. So now we can threshold this a little bit, and we can see very clearly where the peak voxel is within that map that I used to make my mask. So that's how you do it, and the same concept applies if you're using something like Afni's 3D Calc or FSL's FSL Maths command. You just multiply the binary mask and the activation map side by side, and you get a resulting heat map you can use to show where the peak voxel is.